This is a video to help my students with the chemistry review for stoichiometry quest. So let's just go through this kind of quickly and see if you have any questions. You can contact me after the video. So our first balanced equation is potassium chlorate, making potassium chloride and oxygen. So we have a 2, 2, 3 when you balance the equation. So first question, how many moles of oxygen is produced from 2.5 moles of potassium chlorate? Well, we start with the 2.5 moles. We realize we need to figure out how many moles of oxygen we need. So 2.5 moles of KClO3, now we need the mole ratio. So oxygen will be on top. There's a 3 next to the oxygen in the balanced equation. So we're going to put a 3 there. And there's a 2 next to the KClO3 in the balanced equation. So we'll put the 2 there. Now notice how whatever is on the left side is always on the bottom here. And what we're trying to find is always on top. So 2.5 times 3 over 2. It gives an answer of 3.8 moles of oxygen. Next question. How many grams of potassium chloride are produced, if 4.0 moles of oxygen are produced? Again, we're going to start with the moles of oxygen, and then we go to grams of KClO, or just KCl. So 4 moles of oxygen. Now we're going to go to our balanced equation. I see there's a 2 next to the KCl. So we're going to put 2 moles of KCl. And again, there's a 3 next to oxygen. So 3 moles of O2, again on the bottom. And we'll finish up by multiplying by 74.55 grams of KCl, which is the molar mass of KCl. So 1 potassium, 1 chlorine added up per 1 mole of KCl. And that gives us 199 grams of KCl. So this last step is just a mole conversion. And then question 3, we're starting with 14.6 grams of KClO3, and we're going all the way to grams of oxygen. So we'll start with 14.6 grams of KClO3. We'll multiply that times 1 mole of KClO3 over its molar mass. So that's the mass of 1 potassium, 1 chlorine, and 3 oxygens added up. And that's 122.5 grams. We'll then multiply that by 3 over 2. Why? Because there's a 3 for the O2, and there's a 2 for the KClO3. Remember, we're solving for oxygen, so that one's on top, and the KClO3 is on the bottom. Then we finish up by multiplying it by 31.998 grams of O2, which is the molar mass of 2 oxygens per 1 mole. And that gives us 5.72 grams of oxygen. So the first one was an Ohio 1-stepper. The second one is a Texas 2-step. And the last one is an Alaskan 3-step. So that's how they go, depending on what you're given. All right, next equation. And this one's going to be a limiting reactant question. So we have 3 lithiums plus aluminum bromide makes 3 lithium bromides and 1 aluminum. So that's our balanced equation. So now determine the number of moles of lithium bromide produced if there's 2 moles of aluminum bromide and 3 moles of lithium. So now we have 2 different one-step stoichiometries to do. We start with 2 moles of aluminum bromide, and we'll figure out how many moles of lithium bromide should be made. So aluminum bromide is going to be on the bottom. Okay, so let's look. There's a 3 next to the LIBR in the equation, so I'm going to put a 3 there. And the aluminum bromide over here, there's only a 1, so I put a 1 there. So we have 2 times 3 over 1 gives us 6 moles of lithium bromide. Now we'll do another stoichiometry, now with 3 moles of lithium, and then going to lithium bromide. So we start with 3 moles of lithium. And again, there's a 3 for the LIBR, so I'm going to put a 3, LIBRs. And there's a 3 next to the lithium here, so then I put a 3 there. So 3 times 3 over 3 gives you 3 moles of lithium bromide. So now there's a limiting reactant. Why? Because there's 2 reactants in this question, lithium and bromine, and we're given different amounts of each. Now we realize that 3 moles of lithium bromide will actually be produced. Why? Because 3 moles of lithium bromide are formed since Li is the limiter. So in other words, we're going to choose the smaller amount of lithium bromide that's made. We will run out of aluminum bromide, or we will have excess aluminum bromide. We're going to run out of lithium in this reaction. All right, now the next question. Determine the grams of lithium bromide produced from 10 grams of lithium and 12 grams of aluminum bromide. Now here we're going to have this one, the above one, was just 2 Ohio 1-steppers. Now we're going to have 2 different Alaskan 3-steppers. We'll start by converting the 10 grams of lithium into moles by taking 1 mole of lithium over 6.94 grams of lithium. Again, the molar mass from the periodic table. Same mole ratio, 3 over 3. And then we'll multiply that by 86.84 grams of lithium bromide per 1 mole. And again, that's the molar mass of 1 lithium and 1 bromine added together. Okay, and that gives us 125 grams of lithium bromide. Now we'll start with 12 grams of aluminum bromide here, times 1 mole of aluminum bromide over its molar mass, which is 266.6. We're going to multiply that by 3 over 1. Why? In our balanced equation, there's a 3 for lithium bromide here, but there's only a 1 for the aluminum bromide there. Okay, and then, so that's a 3 over 1 ratio, and then we'll multiply that again by the same molar mass of lithium bromide per 1 mole, and we end up with 11.7 grams of lithium bromide produced. Now 11.7 grams will actually be formed, because one more time, the aluminum bromide this time is going to be our limiter. So again, we pick the smaller amount that's made. We'll run out of lithium we'll have excess lithium in this reaction, and we'll run out of aluminum bromide, okay, well before the lithium totally reacts. So anytime you're doing limiting reactant stoichiometry, always pick the smaller of the two answers, okay, to determine what's actually produced. I hope that helps. And again, if you have any questions, please direct that to either my email or to my posting site. Thank you, and hope everything's going well.